In this lecture, we're going to take a look at some of the high-level programming languages that are available to us.
Previously, we talked about different types of high-level programming languages that are available to us. We talked about Ada, C++, C#, Java, and Python. Well, there are more than just the 5 that we talked about. There are a lot more high-level programming languages. So you might be asking yourself, well, why aren't all the programs just written in the best one of these languages? Why don't we just have the one language to rule them all? It just seems like it would make more sense and it'd be a lot simpler if we just had all the problems out there solved using a single language. Well, I mean, there are multiple programming languages, not so much because there are tasks that one language cannot do, but it's more because each language was designed to meet specific needs. So what we're saying here is that one language may be better suited to solve a particular type of problem than other types of languages. I mean, just to give you a couple examples, there are some languages that are better at performing calculations. There are some languages that are better at formatting the output of some result. There are some languages that are better at interacting with databases. So what we want to do is we want to choose a language that's based on whatever task that we're trying to do. If we know we're going to do a lot of computations, we'll use one language over here. Or if we're going to do some other task, we're going to use a completely different language. So the major reason here is just that for the proliferation of programming languages is the proliferation of programming tasks. We want to pick a language that's best suited for that particular task. Another reason is that we have different philosophies for how we should be thinking and writing programs. And this has actually resulted in several families of languages that take quite different approaches from the ones we looked at so far. In this lecture, we're going to focus more on procedural languages. And these are the high-level languages that we've been talking about so far, like Ada, C++, C#, Java, and Python. All the languages that we've talked about so far are procedural languages. Now, there are differences in the way these languages are written. So we're going to just take a look at some of the differences between them. So, I mean, they differ in the way that statements must be arranged on a line, and also how variables can be named. They differ in the details of assigning a new value to a variable. And they also differ in the mechanisms the language provides for directing the flow of control through conditional and looping statements. Now, they also differ in the statement forms that control input and output. Now, they also differ in the way programs can be broken down into modules to handle separate tasks, and they differ in how these modules share information. I mean, we talked a little bit about the syntactical differences when we went over some examples of these languages. Now, in the general sense, these languages are actually quite similar. Just how like French, Spanish, and Italian are all members of the family of Romance languages. So what we're going to do here is we're going to concentrate not really on the syntactical differences, but we're going to focus more on the history and the intent of some of the most important procedural languages. Now, when we say important, we're saying important in that of the many programming languages that have come and gone over the years, these particular languages have become widely used. The first programming language we're going to talk about is Planck'Cool. At least I think that's how you pronounce it. I had to look it up. I'm not so sure if that's exactly the right way. My German is pretty bad. But anyway, this language is German for Formal System for Planning. Now, you probably never heard of this language, ever, and most people would probably say the same thing. This language was designed by Konrad Zuse, who you may remember from before. We talked a little bit about him, built a computer in Germany during World War II. So he designed this language around 1945. And the manuscript for describing this programming language was completed there, but nothing really happened after that. It never became widely used. In fact, it was never even implemented. No one really knew much about the language until 1972 when it was finally published. The manuscript did contain a number of complex algorithms that were written in this language. Now, the language itself, I mean, it was burdened with some obscure notation, but it did contain a number of sophisticated concepts that, if we had known about before, could have very well changed the development of programming languages. So as the very first step to design a high-level programming language for computers, ISYS's proposal was a very important milestone in the field of computing, although it never really got the attention that it deserved. The next language we'll take a look at is Fortran, and the name itself derives from formula translation. So yeah, as you can see here, they actually got for over here and tran over here. So that's how they got Fortran. See what they did there? Now, the language was developed in the mid 1950s. It was led by a group at IBM headed by John Backus. Now, along with some IBM computer users, the first commercial version of Fortran was released in 1957. And this makes Fortran the first high-level programming language that was actually implemented. Now, early computer users were often engineers who were trying to solve problems with a heavy mathematics or a computational flavor. So Fortran had a lot of the features that were ideal for these types of applications. And then the language itself has been updated many, many times. It was updated back in 1990, in 1977, and even all the way up to 2003, and even 2008 with some additional features including object-oriented programming. Now, the early versions of Fortran did not allow the use of mathematical symbols such as the less than symbol or the greater than symbol. They just only focused on numerical computation. And that's just because the key punches that were used back then to create the punch cards did not support those types of symbols. Early versions of Fortran also had no while loop mechanisms. So in order to get the effect of a while loop, Fortran would use an if statement along with a goto statement. And this works very similar to a jump. I mean, if you haven't used a goto statement before, it works just like a jump where you can go to a specific address. The problem with it, though, is that you can go anywhere in the program, which can make it very difficult to read. It can make it difficult to understand. And if you jump to the wrong spot, you can really screw up your programs. So it's usually frowned upon to use the goto statement. And while the code still exists in a lot of high-level languages, it's really not used anywhere. So I'm just going to tell you right now, don't use the goto statement. Just don't. No, just don't. Bad things can very well happen if you use the goto statement. Okay, I'm going to get off my soapbox for now. Now, there is another feature with Fortran which is nice in that it allows what are called external libraries. And these are basically well-written, efficient, and thoroughly tested code modules that are separately compiled and then drawn upon by any program that needs it. So what's really nice about this feature is we basically add these sections of code that perform different types of tasks. And when we know that it works very well, we can include it as an external library. So that means when someone else writes a different program in Fortran, they can bring in that other code to solve their problems. And so what happens in many cases, programmers can use the existing code instead of having to write all that code from scratch again. So I mean, this is a very powerful feature back then, especially being one of the first actually it's the first implemented programming language. So because of this, Fortran was an extremely successful language. I mean, in fact, millions of lines of Fortran code are still in use to this day. And because of its evolution over time, it still remains as an effective language for engineering applications and heavy-duty number crunching for tasks such as climate modeling, computational fluid dynamics, and even computational economics. The next programming language that we'll take a look at is COBOL. Now, the name derives from Common Business-Oriented Language. COBOL was developed in 1959 and 1960 by a group headed by Admiral Grace Murray Hopper of the U.S. Navy. Back then, Fortran and COBOL were the dominant high-level languages of the 1960s and 1970s. So COBOL was actually designed to serve business needs, such as managing inventories and handling payroll. So in such applications, you would have summary reports that were important output products. So much of the processing in the business world concerns updating master files with changes from the transaction files. So for example, you would have a mastery inventory file, and this would contain the names, the manufacturers, and the quantities that were available for various items in inventory. You would also have a transaction file that contains the names and quantities of the items sold out of the inventory or even delivered to inventory over some period of time. So the master file is updated from the transaction file on either a daily or maybe even a weekly basis to reflect the new quantities that were available. And then you would have a summary report that would be printed. Now here's the thing though, the user does not interact with the program at all. It doesn't interact with it directly. Instead, the user would prepare the master file just once and then prepare the transaction file on a regular basis. So the idea is the transaction file would provide the updates to the master file. So I mean, here COBOL was a far more adept at handling file input and keyboard input. In the design of COBOL, particular attention was paid to input formatting of data being read from files and to output formatting both for writing data to a file and for generating business reports with information precisely located on the page. Therefore, much of a COBOL program may be concerned with the formatting. COBOL was also designed such that programs could describe what they are doing in natural language phrases. So as a result, COBOL programs are actually a lot more verbose compared to other languages. So for example, instead of something like as simple as taking the sum and having it equal to a plus b, we would actually have COBOL say add a to b giving sum. And yes, it is in all capital letters. Now this compromise actually sacrifices one of the goals of high-level languages that we talked about before, where we would use standard mathematical notation. But this was a deliberate decision on the part of the COBOL language designers. And this was to allow COBOL programs to be written by people who aren't really as formula-oriented. Let's talk about some of the pros and cons with COBOL. So we'll first by taking a look at some of the good things about COBOL. So it is a very highly portable programming language that's been used across many different COBOL compilers. It's also quite easy to read, and it's very well suited for manipulating large data files. And because COBOL has been around for a long time, there are many existing COBOL applications. It actually provides maybe about as much as 60% of the existing code base, to making it even today one of the most widely used programming languages in the world. Now, with that said, there was still one major issue with the language. You see, developers did not anticipate on COBOL being used as long as it has been being used. I mean, it's been great in the business environment, but the COBOL as a commercial programming language may have been overlooked by those outside the business world, especially when the year 2000 came along. So you may or may not remember, or maybe you heard of the Y2K bug. And this was a bug where in some machines and some languages, dates were stored using 2 digits instead of 4 digits, especially for the year. So when we hit the year 2000, many machines still thought it was 1990 instead of 2000. And there was some widespread panic back then because people thought the machines were going to fail and all sorts of errors were going to happen. It really wasn't that bad. But COBOL was one of those languages that had that bug. So there were massive updates that were needed in COBOL to make sure that the dates were properly displayed.